start the transformations unit today. And yes, it's more graphing. And here is a summary of all the graphs that you should hopefully see before or know about. There's a couple of here that we have done already so far this year, like our constant graph, or linear, or absolute value. Maybe you haven't seen the greatest integer. This one's not that common, but it'll be still nice for you to know what it kind of looks like. The quadratic you've seen last in grade 11, the cubic you've seen this year, the square root, a bit of the cube root, and of course your trig functions. So we're going to transform some of these graphs, more particularly the absolute value that we're going to transform, maybe the quadratic, the cubic, and the square root. Not so much the trig functions, we've already dealt with a lot of those in the trig unit. And we'll be also transforming other type of weird looking graphs as well. So we're just going to focus on one thing at a time here. We've already talked about horizontal and vertical transformation, so hopefully this will be kind of a review for you. So for horizontal translations, the rule is that we're going to do the opposite of what we think it is when it's attached to the x plus h right here. So you would think it would be to the right, but as we said, move the entire function to the left 8 units. And if you have f of x minus h, that means we'll translate it to the right 8 units. So let's use x squared as an example of how we're going to translate. So let's just draw x squared. Remember that our vertex would be at 0, 0. Then you'll have points at y equals 1 on either side. X equals 1 and negative 1. And then you would have also point at 2, 4, and also negative 2, 4, and so on. These are enough points for us to connect the dots. And then slightly extend our graph here. So when you're doing these transformations, I think the best way for you to do it is to write out some specific points that we know from our original graph. So we know we have a 0, 0. We know that we have a 1, 1 and a negative 1, 1. And this will be enough for me to get the shape of our new graph. So this is x, y. And what I want to transform it to is I'm going to move my function 3 units to the right, which means I'm going to have to add 3 to my x value to get my new coordinate, and I'm not doing anything with my y. So I'm just going to rewrite it like this. So now I can plug in some values into what I wrote to find a new point. So for 0, 0, my x value is 0, so I'm going to plug that 0 in. So 0 plus 3, and my y value is 0. Which means that my new point will be 3, 0. Here, I have 1 for my x value, so this will be 1 plus 3. And then my y value stays the same as 1, so my new point is 4, 1. So we are just transforming from our original to the new function that we want. And then lastly, I have negative 1 plus 3, which is 2. And my y stays the same as 1. So these are the points for my new function. I'm going to do it in a different color. So I have 1 at 3, 0, 4, 1, and 2, 1. Connect the dots slightly here. And then here is our transform graph that we moved 3 units to the right. And then you're done. So let's describe the new function. All we need to say is just move f of x 3 to the right. Or you can even write out the actual equation for this function. And this would be, instead of writing, here we have f of x is equal to x squared. F of x minus 3 just means we're going to replace this x with x minus 3. So all of x minus 3 squared is actually the function of what we just drew. Here's another example. We have an absolute value function here, and it says give the name of the original one because this is the transformed one, and then describe the transformation and then sketch it. So our original function is y equals absolute value x, and this is the absolute value function. So that's the name of the original. And this is describe the transformation. Here, this is the same thing as saying x plus 2, because we have a double negative there. That's the same thing as saying x plus 2. That means we're going to shift our absolute value function to the left 2. So shift y equals absolute value x to the left by 2 units. So that's our transformation. And now we're just going to sketch it. So usually we'll have the pointy vertex at 0, 0, but now we're going to shift it over 2. And then we would have points at -1, 1 here, -3, 1. And then we'll set our graph a bit, and then that'll be our absolute value function. Just like in the previous question, we could have written our points, 0, 0 of the original function, and 1 was part of the original function, and -1, 1 is our original function. And then we can transform it so that we have x minus 2, because we want to go to the left and then leave our y alone. And if I do that, I can find my points, which are the ones that I actually drew onto my graph. So these points I found on this side here are the points that I've actually drawn on my graph. So my original function summary was y equals absolute value x, and my new function here, g of x, was the absolute value of x plus 2. All right, so for our vertical translations, this one you don't have to think about the opposite. When this says plus k, that means you're actually going to go up. And if it's minus k, then you're going to go down. So again, we're going to use x squared as our example here. So that's y equals x squared. And then now I want to translate 2 up. So just to be formal about this, I can find the points of my original, and I want to transform it so that I'm going 2 up in my y. So it'll be x will stay the same, and then I'm going to have to add my y. So my new points is 0, 2, 1, 3, and -1, 3. So then it's going to look something like this. And this is my new function. My new function as g of x, for example, and this would be x squared plus 2. And you can describe it as well. We move 2 up is the actual transformation from f of x. So a g of x here, our new function is x squared plus 2. Here, similar to example 2, we're going to go backwards. We're given the transformed equation. We're trying to find the original. So the original we know is an x squared parabola. And our translation is going to be the one that's given to us, which is g of x, x squared plus 6. And this is moved up 2. Or sorry, move up 6. That was the translation between the original and the new one. So we got the original function, which is the parabola. We described the transformation because we're going to move up 6 from the original, and then now we're going to sketch it. So our vertex here would usually be at 0, 0, but because now we're going to add 6 to our y, our new point is going to be 0, 6. Our point 1, 1 will turn into 1, 7. And our point from the original negative 1, 1 is going to turn into negative 1, 7. And then now we can just graph this. So 0, 6, 1, 7, negative 1, 7. I can connect those dots and extend a bit. And that's our x squared plus 6 graph. So now let's do a little bit of combination of the vertical translation and our horizontal translation. So first we're going to start at 0, 0. So it's a sketch y equals x squared first. So I'm going to do that. That's y equals x squared. And now we want to do the translation. So the reason why I'm showing you to do the points is because sometimes in the next few lessons, our translations get more complicated and it's not going to be very easy to see. So it's better to write down our points and then do the translation. So we know that we have 0, 0, our vertex, we have 1, 1, and negative 1, 1. Like right now, 3 points. In the future, you might want it more depending on how complex your graph is. But with this graph, you can already see the shape of it by just doing 3 points. So that's why I'm only sticking to 3 points for the x squared graph. But like I said, in the future, it really depends on the original graph you're given. Sometimes you need to do 4 points, 5 points, maybe even 2 points, depending what it is. Okay, so we want to go from xy to a translation of x minus 4. Remember, it's plus 4, means we're going to move 4 to the left, so that means it needs to subtract. And then our y value is going to be subtract 8 from our y values. So now my new points will be negative 4, negative 8. I'll have negative 3, negative 7. Here I'll have negative 5, negative 7. Those are the points I'm going to graph. I'm going to connect the dots, and then that'll be my translated graph. So negative 4, negative 8 is down here. Negative 3, negative 7. And then negative 5, negative 7. So I'm just going to extend my graph a bit here. And that would be my translated graph. I can call this f of x plus 4 minus 8, or I can just plug it into my function. Like I already know f of x is equal to x squared. I'm just going to plug in x squared, or f of x equals 2. So if I want f of x plus 4 minus 8, then I can replace f of x with f of x plus 4 with x squared. This would be my new function. So I can call this gx x plus 4. C inside that, you're going to put in your x. So in my bracket of x plus 4, so instead of just putting x, I'll put x plus 4 squared. Minus 8 is on the outside, so I can just leave it on the outside. Alright. Example 6, we have y equals root x is translated 2 units to the right and then 1 unit down, and we want to know the equation of the image graph. So this means x, if it's to the right, that means I need a minus, and it'll be 2. And then unit down is going to affect my y value as minus 1. So my new graph here, this x minus 2 has to stick together, and it's going to be underneath my root sign. So the x. And remember, the minus 1 is your shift of up and down, and that would always be outside of, if it's a squared, a root sign, a sine, or cos, or whatnot, this is going to be outside of it. So just be minus 1. So this is your equation of your image graph. So remember, this is the x, this affects the x, as the x, and this negative 1 affects your y. Describe how the graph of y equals 1 over x could be translated to create x plus 1 equals 1 over x minus 2, and then what are the asymptotes. So this is what we just covered on your test yesterday. I can rewrite this. Got my plus 1 on the other side. Y equals 1 over x minus 2 and then -1. So how is it translated? Remember how we would have an asymptote whenever our denominator is 0? So usually if we look at y equals 1 over x, our asymptote is at x or at 0. But now we moved it so that our asymptote is at 2. So same concept applies here. -2 is attached to our x. So when we have a minus, it means we're going to go to the right. So that means we're going to go shift to the right. And then if you look at our y value, what's affected, it's that single number that's hanging in there outside of our fraction. That means we're going to have a horizontal asymptote of -1, or you could, in this case, change it down 1 unit. And then my asymptote, I have a asymptote, and that occurs at y -1. And that's it for that question. So hopefully some of this is, or most of it's pretty much review. The only thing that's new about this graph, and then using a broken down method in order to find our new points. And like I said, I'm trying to, because in the next few lessons we're going to look at more complex graphs in which this would be more efficient for us to find the new graph. Problems. If you have any questions, please ask me tomorrow.